Now we will simplify a rational expression. We have 3 simple steps. Factor the numerator, and we see that there is a GCF in the numerator of 3, and we have x plus 4 left, so the numerator is factored. Step 2 says factor the denominator. Well, in step 2, we don't have a GCF, but we do have a difference of 2 squares. So that factors to be x plus 4 times x minus 4. And then step 3 says to cancel out common factors from numerator to denominator. And so the common factors that we see are x plus 4 in the numerator and this x plus 4 in the denominator. So we cancel those 2 factors out, which leaves us with an answer of 3 divided by x minus 4. Now, let's have you try this one. Pause the video, and then you factor the numerator, factor the denominator, and then cancel out common factors from numerator to denominator. Now I'm going to work it out, and let's see if we get the same values. Factoring the numerator. And now I am factoring the denominator, and that factors to be x plus 5 times x plus 3. And now let us cancel out common factors. The x plus 3 in the numerator cancels with the x plus 3 in the denominator. So our answer is x minus 4 over x plus 5. Now, you can choose to leave the parentheses or take them off. It doesn't matter. Now, we will multiply rational expressions. Okay, in this problem, we are multiplying 2 rational expressions. But, surprisingly, we will use the same steps for simplifying rational expressions. We're going to factor all of our numerators, and then we're going to factor all of our denominators, and then we will cancel out common factors from numerator to denominator. So we're actually not really multiplying anything. So let's have a look to see what happens. My first numerator is 5x. There's nothing to factor because that's a monomial. My next numerator is 3x minus 3. There is a greatest common factor of 3. And so we factor that. So we factored our numerators. Now let us factor our denominators. The first denominator, x squared plus x minus 2. When we factor that, that factors to be x plus 2 times x minus 1. And then our second denominator is x squared plus 3x. And let us factor that. That factors to be x and then x plus 3. Now, let us see if we have any common factors from numerator to denominator. I see an x here that I can cancel with an x here. And then I have x minus 1 that can cancel with this x minus 1. And so, so that takes care of all of my common factors that can be canceled from numerator to denominator. Now, what we have left in the numerator is 5 times 3, which is 15. But in the denominator, we don't have to multiply out the x plus 2 times the x plus 3. We can just write it out and leave it. So this is our solution. Now we will divide rational expressions. But let's take a look back to when we were in 5th grade and we had to divide fractions. So let's say we divided 2/3 and 1/2. We know that when we divide, we really are multiplying by the reciprocal. So we did 2/3 times 2. And then we multiplied numerator times numerator and denominator times denominator. Well, that principle of multiplying by the reciprocal holds true when we divide rational expressions. Let us look at this dividing problem. First, we need to realize that we have to multiply by the reciprocal. So the first ratio times the reciprocal of the second ratio, which would be x squared minus 4x over x squared minus 36. Now, we're back to a multiplying problem. So we're going to go through the steps for multiplying. Factor our numerators, factor our denominators, and then cancel common factors. So let us do that now. Of course, the first numerator, we really don't have to factor anything because it is in factored form. Our second numerator, we have a GCF of x, which leaves us with x times x minus 4. Now, our first denominator factors to be x plus 6 times x minus 4. And our last denominator factors to be x plus 6 times x minus 6. Now let's see if we have any common factors. The x minus 6 here with the x minus 6 in that denominator. The x minus 4 here with the x minus 4 in this denominator. So it looks like we've canceled all that we can. Notice that we cannot cancel the x plus 6 in the first ratio with the x plus 6 in the second because they are not in a numerator to denominator ratio. So that leaves us with an answer of x in the numerator and in our denominator, x plus 6 times x plus 6. Now, some of you may be asking, can't we write that denominator as x plus 6 quantity squared? You may, but you don't have to. Now, what I want for you to do is just to write any questions that you may have.